Learning a new language takes time and effort, but did you know that by leveraging AI you can drastically speed up your progression? I have lived in Japan for a year now, and I often need to check how to say something or if a message I want to send to a friend is correct. While ChatGPT with a good prompt works well, we will combine it with text-to-speech using Azure, React Fiverr for a 3D animated teacher, and Next.js for the API.
Pizza が好きですか?
If you are as excited about creating your own 3D AI teacher chatbot as I am, don't forget that bringing your virtual assistant to life requires some amazing 3D models. Thanks to Fiverr, you can access a vast marketplace of talented creators to create the perfect one to make your project unique. For this project, I asked 4 creators to create 3D models for me. For the classroom, I searched artists in the graphic and design 3D game art subcategory. To find the right ones, I filtered on Blender and FBX file format and opened creator pages with styles I liked. To make my choice, I looked at their portfolio, reviews and pricing. I ended up picking Remigiusz and Adityia. I sent them the same requirements with an explanation of what I want and some image references to illustrate what I have in mind. I ended up with this classroom from Remigiusz for a total cost of $140 and this one from Adityia for $80. Then I repeated the process for the teacher. I looked for a 3D character designer and found 2 affordable artists with really good style. I asked Biapo for a female teacher in her own style, which led to Nanami Sensei for $100. And I asked Sahasup for a male teacher in his manga style, which led to Naoki Sensei for $70. I also had very specific requirements, such as having a Mixamo compatible rig for the animation and Creature Azure compatible blend shapes for the text-to-speech. Both were perfectly respected. You can find the links to Fiverr and to each creator in the description and get 10% off with the promo code Wawa Sensei at the checkout process. I will teach you how to build the whole application, but if you are only interested in how to use it and deploy it for you, stay until the end. I will show you how to do this too. Now our models are ready, let's create our Next.js project. We will follow Next.js documentation to create our app, go to automatic installation and copy this command, paste it in the terminal. What is your project name? I will name it R3F AI language teacher. Do I want to use TypeScript? No. ESLint? Yes. Tailwind? Yes. Source directory? Yes. And app router, which is the new way that Next.js handle routes, I will keep it to yes. And I don't want to customize the import alias. It's creating the project based on those settings. Now it's created. I need to open it with File, Open Folder. Perfect. Now we are inside our project. We need to do a few things before starting it. First, by default, it's using npm, and I don't like it, so I will remove the package lock.json. And I will do yarn to install the dependencies with yarn instead of npm. Now it's done. Let's try yarn dev to see if our project is running. We need to follow that URL, and we arrive on the default page from Next.js. Now we have the Next.js boilerplate ready. Let's add React Fiverr and load our 3D models. Let's install three.js and React Fiverr. Let's stop the project, run yarn, add 3 at React 3 Fiverr and at React 3 dry. Now it's done, we should be able to run the project again, and let's set up the 3D. We can hide the terminal, go to source, and we create a new folder that we will name components for all our 3D parts. Inside, we will create a new one, which is named experience.jsx. Export const experience. We will return an empty fragment with our 3D canvas from React Fiverr. And just to see if it works, a box from dry with a mesh normal material and orbit controls. Let's display the 3D inside our page. So in the app folder, inside page, this is the default page they did. So we will get rid of it. And instead we render a main with age screen and min age screen to take the full height of the screen. And inside, we put our experience. If we reload, we have an issue because with server component, it's trying to render the 3D part. What we need to do is inside our experience to say it's only front end. So it doesn't have to be rendered inside the server component. To do this, we put use client on top. And now we can see a square and we can move it. We see our cube. Instead of rendering this box, we will render our model. We will place them in the public folder and create a subfolder named models. And we drag and drop all the files that you can find on the final repository. Now let's display the classroom. The first one will display the default one. We use GLTF with the source. It's like an image, but for loading GLTF files, because we don't want to do any processing on the classroom itself, which is /models classroom _ default.glb. If we look at it, it's completely black. We need to add some light. For this purpose, we'll use the environment component with the preset sunset and an ambient light with an intensity of 0.8 and pink. Now we are able to see our classroom. We can rotate, but what we want is to fake that we are in first-person view. So we won't be using orbit control for this. Let's get rid of orbit controls and we will create a component named camera manager. This is where we'll be able to do nice transition later. But for now, it will just return camera controls from try. And here we will use our camera manager. To fake to do a first-person view, what we do is we set our camera position to 0, 0 and a very low value on the z-axis. Now, if we try, we can look around as if we are in first person, but the position of the classroom is wrong. Let's go to our GLTF position and we positionate it. Now it's better. We are at our seat here and we can look around. But we want to define how much our user can zoom in, zoom out, and what they can do. On our camera control, we add a minimum zoom and a maximum zoom. So we limit how much our users can zoom. Then we set the rotate speed to a negative value. So we have the real feeling that we are moving the camera. Then we define the action for mouse button. So left one will be to rotate the camera and the wheel will be used to zoom. Then touches, we will also be able to rotate and zoom. The comments here are because action.rotate is from TypeScript and I'm not able to import it. So I just know the value is 1. I got it from the source code of the library. Same for action.zoom, which is 16. Now I can move my camera. The side of the rotation is accurate. I can zoom in to a maximum of 3, which is this. And I can zoom out, but not too much. So I'm always at my seat correctly. I can look behind. There is no one. The teacher is not here. So let's make it arrive. For the teacher, we create a new component. We name it teacher.jsx and export const teacher. And we'll return a group with different props we will get as parameter. What we will need is the teacher and the props. To load our teacher, we'll be using useGLTF with the teacher based on the name that we get as a parameter. And we need to display it here with primitive object scene. It will display our 3D model loaded. We can also preload the GLTF models here. So what we will do is we declare our two teachers and teachers.forEach. We will preload with use GLTF, preload the teacher models. So we'll be able to add a spinner and it will preload all our models. Now let's try to display our teacher. Go to the experience. Next to the GLTF of the classroom, we'll add our teacher. The teacher, we will set Nanami. We positionate it in our classroom with the position. We can see she is here, but we need to scale her up and to rotate her toward us. Scale 1.5 and rotation Y deg to rad of 20, which converts the degrees into radian. Now she's perfectly sized and looking at us. Before going further with the 3D, let's create our API route for our AI with ChatGPT. To create our API route, we go inside the app folder. We create a subfolder named AI. And to make an API route, we need to name it root.js. We will need to use OpenAI library, yarn add OpenAI, and we will follow the documentation to know how to use it. So first, we need an OpenAI API key. For this, you need to create an account on OpenAI developer, follow the process, and you will get an OpenAI API key. I will provide you the link in the description. When you have it, you will need to set it up as an environment variable. To do this, create a new file at the root of your project, name it .env.local which will be used only when you are on your computer in local mode, and add OpenAI API Key. And then you paste your API key here. Of course, I won't show you mine, but it should start with something like sk-something. Now we have our environment variable. We can use new OpenAI with our API key, and Next.js will automatically load the environment variable from the environment file. We need to import OpenAI here, and now we can create our route. To define a route with Next.js, you need to do export async function get for a get request. For simplicity purpose, I will be using get request, but you can use post if you need to, and it's better in some cases. Then we need to do our API call to OpenAI like in the documentation. This is what I ended with. I will show you from the beginning, which is here. I have a get request parameter, which is the speech, if it is formal or casual Japanese. Then based on that, I will be using an example for my prompt. The examples are the following. So if I go up, I have the formal example. It's a JSON object containing the Japanese split by word and how to read, because in Japanese you have kanji. You need to know the reading, and the reading is using hiragana, katakana that are simple to read when you know them. Then in my example, I'm showing what kind of response I'm expecting. So the grammar breakdown about this sentence here. We have the English, do you live in Japan? Then we have the Japanese, which is split by word. So we are able to have the reading. It's always the same format for Japanese. It's an array of words. And then we have the different chunks. So for example, we have the Japanese here, Nihon, which means Japan, and the grammar, it is a noun. Then we have ni, which means in, and it's a particle. Then you have sundeimasu, which means to live, and you have the explanation of why. And you have ka, to mean it's a question. And because in Japanese you have the polite form and the casual form, I made a casual example, which is slightly different. It is here. So the AI is able to determine which one to use based on the get parameter we have. Using that parameter, I create my prompt, which is here. So role is system. You are a Japanese language teacher. Your student asks you how to say something from English to Japanese. Of course, you can adapt it if you want to create another bot or another language or another purpose. You should respond with English, which is the English version. I give an example. Japanese, the Japanese translation split into words, and I add the example, which is using stringify of our object. So if it's formal, I'm using the formal one. If it's casual, I'm using the casual. And then the grammar breakdown. And I'm using the grammar breakdown from the speech example. Then for my prompt message, I add another one showing the final JSON structure I want and I expect. So it will be very simple if it never changes in the front end to manage those data. So it's just empty values. And finally, I'm using the user input. So user, and we add how to say, then the question we get as a request parameter. If we don't get one, we will say, have you ever been to Japan? And then in Japanese, in either formal or casual speech. I'm using GPT 3.5 Turbo because if you want to use GPT-4 or above, you will have an error if you never paid before with your API key. And very important, if you want to be sure that you have JSON from OpenAI, you can add a response format parameter. Type is JSON object. And because I defined the format, I'm sure I always have that format. Then we console log it to be able to see it in our log, and we return it to have the response when we call the API. Let's try to call it to see if it's working without parameter. And we have an issue, page not found. I guess it's a problem in the root app AI. Okay, I need to create a subfolder named API and then put our AI folder inside it. Let's try again. It's fetching the API, and we have the answer from OpenAI. I can use pretty print. Have you ever been to Japan? I have the Japanese, but the characters are not displayable here, but it will work inside our front end. And we have the response as expected. We can try instead to have you ever been to Japan? To add a query string parameter. So it is question is equal to do you like cheese? And here we can see it's working. It's saying, do you like cheese? And I guess the characters are accurate too. To be able to see the Japanese character, we can see in our server console here, do you like cheese? And we have chizu ga suki desu ka, which is correct. Our AI is ready. We will want to convert the text generated by ChatGPT into audio. For text-to-speech, we'll be using Microsoft Azure Speech SDK, What is convenient is it generates the audio, but it also provides the Viseme to show the mouse pronunciation on the character. We just need to follow the quick start, install the Speech SDK. So first, we need to install the Speech SDK for JavaScript. We are using Node.js because it is our backend that is doing it. So we just need that line here, yarn add and Microsoft Cognitive Service Speech SDK. Then we need to import it. We will create a new route for the text-to-speech. Here on the left, app API, new folder, TTS for text-to-speech, and a new file, root.js. Now we can do the import of the SDK. Again, for convenient purpose, we will be using a GET request, so I can show it to you in the browser. And we will need an API key. To have an API key, I will provide you the link in the description. You can click on Start Free, follow the procedure, and generate your API key. Let's go to Text-to-Speech Quick Start. And they provide the explanation on how to get your API key. So first, you created your Azure subscription. You have already done it. Then we need to create a speech resource in the Azure portal. So let's follow the link. It will ask you to log in. Then the subscription, you choose your Azure subscription. The resource group, you can create a new. Me, I already have AI teacher, but just a name. You hit OK and it will create it. Then you choose your region based on where you are. Me, I chose Japan East. Then you set the name and the pricing tier. So you can use the free one. You do review and create. Then you go to the next step, get the keys for your resources. And you still follow the procedure. After your resource is successfully deployed, select next step, go to resource, and you will be able to see your key. So you should arrive here. Go to keys and on point and copy the keys that you will get here. When you have the keys, you can add them in your environment file. So OpenAI API Key, you should have your key here. Then add a speech key and speech region. It's easier if we keep it inside the environment file. Now inside our root, we can create our speech config using the speech key and the speech region. Then we create our speech synthesizer and it requires a voice. Me, based on the name of the teacher, I will be using either Nanami or Naoki. To find the different voice available, you can follow the link and you have all the different voices available. So me, I will go into Japanese, but you have all languages. Japan, okay, here you have all the different Japanese one. So we are using Nanami Neural and Naoki Neural. Then we want to generate the audio stream from the SDK. So we return a new promise and we call speak text async. It requires the string we want to play the audio for. So either I'm using the text parameter, or if I don't have one, I'm excited to try text to speech. To handle the buffer is something you find in the documentation. We need pass through. So let's import it. And finally, the response of our route, we will generate the audio MPEG header. So it will automatically know to play audio. And we don't need a name, so we just name it tts.mp3. It's not meant to be downloaded, just played in our browser. Let's try it inside our browser.
こんにちは、元気ですか?
And it's correctly working. But because later we will want the audio to be synced on the lips of our character, we'll be using Visemes. This is what you can see in the documentation, get facial position with Viseme. And it's showing us for the different IDs we have. So 0 is when it's in silence. 1 is when the mouth is open, etc. And it's able to fake that our character is playing. To get the Visemes, below the speech synthesizer, we add a Visemes array. And on Viseme received, we will add them into our Viseme array. So if we call our AI TTS again,
こんにちは、元気ですか?
You can see we had all those console log with when it happened and the Viseme ID we should display on our avatar at that moment. But currently, we are not returning it inside our audio file. We need to return that information, so in the front end we'll be able to exploit it. But because our response is an audio stream, we can't give it as a JSON response in addition. So instead will be a small trick, which is to pass it as a header. It's not the cleanest way to do it, but it will work because we don't have very, very long sentences. So we shouldn't reach the limit of header size. We just set Visemes is equal to stringify of our Visemes array. And by doing this, we can also comment the console log here. Let's try it again with the network tab opened. If we go into preview, we have nothing because we just have the audio played. But if we go to header, response headers, here we have the Visemes, which is the array we created with the time in milliseconds and the Viseme to use. So 20, 8, 19 based on the current time of the audio. Time to go back to the front end, to share data between the HTML components and 3D components and have the API logic in one place. We will use Zustand as a state management solution. If you don't know it yet, you will prefer it over Redux. To install Zustand, we need to copy it, yarn add Zustand, go in another terminal, yarn add Zustand, and inside the source folder, here source, we will create a new folder named hooks, which will contain our use AI teacher.jsx. We use create from Zustand, and you will see how simple it is. So const use AI teacher is equal to, and we use create, and we have access to set and get, and we create our store here. We need to be available everywhere, so we also export it. And this is our global store. So we need to define the different variables and actions, and we are sure they will be synced throughout all the application. So what we want is the different messages we will get from the API. So it's an array of messages. We also want to show the current message, which is the one that will be played, set it to null. We will also be able to change the teacher. So we'll select by default teachers of 0. And let's make it simple for the moment. We want a method to change the teacher, so either the 0 or the 1. So we'll create a method named setTeacher. It will take the teacher as a parameter. What it will do is set and teacher. You could do teacher is equal to teacher, but it's the same. And it will simply update our teacher without affecting the rest of the state. And every time we'll get the teacher from use AI teacher, it will be the latest value. Let's create one to change the classroom. We'll take the default one, but we can change to another one. We could add some checks if the classroom exists, but it's fine. Our frontend will only use values we have. We'll add some other settings that we will need later. For example, the furigana, which is what we show on top of the kanji to know the reading, what we saw when we did the OpenAI part. If we want to display the English translation, and what speech we want to use, either formal or casual. Now time to make our API call. So first we want a variable to know if we are fetching some data. So we call it loading and we set it by default to false. We create a method named askAI and it takes a question as a parameter. If there is no question, we won't fetch the AI. Then we create a message which contains our question and we generate an ID for our message. So if we want to perform updates on it later, it will be easy to find it. Generate the ID, we get all the messages with get.message, which is our array here. So because we have access to get, we know it's the latest value. And .length. So the first message will be 0, then 1, 2, etc. Now we created that message, we'll set loading to true. Then we will get access to our speech, which is the setting that also is in our state here. Currently it's formal. And when we have it, we will fetch our API route /API/AI with the question and the speech. When we have the answer, we do await arrest.json, so we have access to it in JSON. And inside our message, which is here, we set the answer is equal to the data. We also store in the message the speech that was used. That way we'll be able to display in front end if it was casual or formal. And we set our current message with the message that we just created. So we will be able to play the audio for it and display it on the blackboard. When we have updated our state, we set loading to false because we ended to do some API call. And we append the new message to the current message in our state. And now we have the text answer from the AI. We need to play the audio. So we create a new method named playMessage, and we'll pass it the message we just created that contain all the information we need. playMessage, we will call it directly from the ask a question, but also from the front end when we want to play the audio again. So what we do is we set the current message to message. Even if it is the case here, when we fetch the question, if we just use the play button on the blackboard, we will need to set it to current message. Then, if our message doesn't have an audio player, which means we didn't fetch the audio for that message yet, which is the case here. Then we will set loading to true because we need to do an API call, and we call our TTS route with the current teacher and the text. Because it's an array of Japanese words, we need to do a map and to join them based on the words it contains. Then we get the audio from the response, but we also get the Visemes from the audioRes.headers. Then we create an audio URL using the audio we get, so we are able to play it inside our browser. We create our audio player, and inside our message, we add the Visemes, and we add our audio player. On our audio player, what we will do is when it is finished to play that audio, we'll set current message to null, so we are not showing that our teacher is speaking. And then we set that we are not anymore loading, and we update our message array with the update so it contains correctly the Visemes and the audio player inside our array of messages. Let's create a last method to stop message. If in our frontend we want to pause the audio, we create stop message, it will pause it and set current message to null. Now to use it, let's create our UI. I found some inspiration on Dribble, and everything that looks bad comes from my mind. Let's create a new component named typingbox.jsx. For our typing box, we need the askAI method. We need to know if we are currently loading, and the question that we are typing inside that component. Then we will create an ask when we click on the button to say ask AI with the question we are typing and to reset the input with an empty question. Then it's just HTML display. On bottom of the screen, I made sure it was responsive. A title, how to say in Japanese, and type a sentence you want to say in Japanese, and AI Sensei will translate it for you. Then if we are loading, we will show a spinner, but if we are not loading, we will display our input. When the value change, it set the question, which is our variable here. And we display the value of the question inside our input. And if we press enter, we will ask the question. But we also have a button. On click, it will do ask. Let's add the component inside our experience. So it has to be out of the canvas. We put it on the bottom of our screen and we add our typing box component. Let's try it. We have our box here. Hello, my name is Wawa.
こんにちは、私の名前はワワです。
So we had correctly the audio, but we need to display it on our screen and make our teacher speak. To display it, we will add an HTML element inside our scene here, HTML, so we can display it in 3D. Be sure you use the dry import from HTML and not the one from Next. Let's set its position to the right place. And instead of putting everything here, we will create a new component that we will name messageslist.jsx. For our messages list, we need all the messages from our state. We need the play message function to call it manually when we click on the play button. We also need the current message, and we need the UI information, as if we display English, if we display the furigana, and the classroom we are currently displaying it into, so we can size our Blackboard accordingly. Then a nice effect is on our container containing other things. We will scroll down to the bottom when we have new messages. Then to avoid rewriting code, we create a render English method that will display our English text with the right settings, with the right color. We do the same for Japanese. Here it's a bit more complicated because we have an array of words, but we loop through all of them and display correctly the things. We check if we display the furigana, and if we have a reading, if we have, we display it on top of our Japanese word here. And then it's just HTML. So we size our div based on the classroom. If we are on the default, it is this size. If we are on the alternative one that we didn't set up yet, this is this size. And we need to have a reference to it to be able to do our scroll method here. Then if we don't have messages, we will display on the Blackboard Wawa Sensei Japanese Language School. And then we loop through all our messages. We display the speech and the question in English if we are displaying English, then the Japanese answer. And then if we are a current message, which means we are playing audio, we will have a button to stop playing the audio and another button to play the audio if currently we are not playing audio. Then below, what we want to do is display the grammar breakdown. So we loop through the grammar breakdown of our backend answer. We display the English, Japanese, and all the explanation from the grammar chunks. Now let's add it to our experience HTML component, messages list. We can see our hello, my name is Wawa. but we need to configure our HTML component to work nicely and to be displayed here. To make the position work, we need to add transform. Now it looks like it is in 3D. It's not following my screen, but we need to push it back. It's currently too much zoomed in. For this, we can use a distance factor. I'm using 0.5. That way the quality will be good because we put everything in big. So we have a nice pixel density. And now it is in the blackboard. It appears a bit far, but remember we can zoom. And even if we full zoom, we can see it nicely. Let's try to play the audio.
こんにちは、私の名前はワワです。
And it's working perfectly. Let's add the settings button to be able to change the teacher, the classroom, and if we display Furigana and English. For this, we create another component. We name it board settings.jsx. Inside our board settings, we need the access to Furigana set Furigana, English set English, teacher set teacher, speech set speech, and classroom set classroom. It's just settings that we can update from here. Then we will return an empty fragment. It will contain different absolute position div. This one is absolute right 0, which means it's on the top right, and bottom full, which means it's pushing completely from the bottom, which means it will be a bit above on the top with a margin bottom of 20. We loop through our teacher and we display their picture, and when they click on their picture, it will change the teacher. Then absolute left 0 and bottom full, so it's the top left. Same principle. We have a button to set the classroom to default or another button to set the classroom to alternative. Then absolute left 0 top full, which means it's the bottom left. We have a button to set the speech to formal and a button to set the speech to casual. And finally, absolute right 0 and top full, which will push us to the bottom right. We have one button to display Furigana and one button to display English. First, we need to add the pictures of our teachers. So we need inside the public folder here to create a new one named images and drop the beautiful pictures of our Sensei here. Now we are fine. We should go to experience and next to message lists, add our board settings component. Now we are able to switch between displaying Furigana or not. You can see it's the little character here on top of the Japanese translation, and same for English if you want to display it or no. We can also switch to casual mode. If I type, do you like pizza in casual?
ピザ好き?
To finish with the UI, we need to go to layout and add a custom font instead of the inter. To know how fonts work with Next.js, you can check their documentation. They show the guideline to display Google Fonts. Instead, we will replace it with Roboto and NotoSense.gp. You need to import them. So now we generate a variable. We named it font Roboto and font NotoSense. And we need to add them inside HTML here. And here, the default one will be roboto.classname. Now we need to go to Tailwind config. Inside the extend, add our font family. So sans is equal to var font Roboto and Japanese is equal to font NotoSense. Now if we look, we take this text, it is Roboto here, and the Japanese one is using NotoSense. Now let's connect the Visemes from Azure to our model blend shapes. If you look on the model that I got from the Fiverr Creator, I asked for blend shapes. So if you go here, you can see something named shape keys, and you can see different blend shapes. You have 0, 1, 2, 3 until 21, and eye close. So eye close, if I change the value, it makes our character blink. And the other one are mouth positions. Those mouth positions correspond to the Visem ID I showed you earlier and we get from the backend. To be able to animate our blend shape, we create a method named Lerp MorphTarget. It takes the target, which is the name of the blend shape, the value between 0 and 1, and the speed to make it. Then it iterates through all the objects inside our 3D model, and if it finds a skin mesh with the corresponding target as a morph target, then we will lerp that value into the target value that we find here. So basically what we do is we say we want the 19th at 0.5 and it will lerp smoothly until 0.5. To have access to our Visemes and our current message, we need the current message from your AI teacher. And in a use frame, we will call the different lerp morph target based on our current values. So if we have a current message and that it contains the Visemes and the audio player, then we loop through all the Visemes that we get from our current message. And what we do is we check at what time we are currently playing the audio and if we are over the current Viseme. So remember, Viseme of 0 is the time and Viseme of 1 is the value. If it's the case, we lerp our MorphTarget with Viseme 1, so it will be a number between 0 and 21, 1 to apply that Viseme, and 0.2 as the speed time. Let's try it. Do you like cheese?
チーズが好きですか?
And you can see we have an issue because all our MorphTarget are set to 1 currently. So before applying the new one, we need smoothly to reset the MorphTarget for each of them. So from 0 to 21, we set them to 0. And now if we try it again,
チーズが好きですか?
the mouse worked perfectly. Let's also make our character blink. This is a code that I imported from our project Virtual Girlfriend. We need a use state and a use effect. And every second to 5 seconds, it will just blink the eyes, setting a state to true or false when we need to blink. And in our use frame, above the talking part, we will handle the eyes blinking. If we look at our teacher, you can see from time to time, her eyes are closing. Right now. To animate our character, I prepared the animations with Mixamo and Blender. If you want to learn how to do it, it's in the Virtual Girlfriend video, link in the description. To attach the animation, we need to create a reference on our group. Go here on the group and add the reference. Then we need to know if we are loading. We get the animations from the file and based on the teacher. We have the actions using use animation with our animation on the group. And we have a state to store our current animation that we are playing. Then in a use effect, we will handle the change of the animation based on the current message and if we are loading. So if we are loading, we'll set the animation to thinking. If we have a message, it means our character is currently talking. So either we'll be using talking or talking to animation. You can add more if you want. And set animation idle the rest of the time. Then in a second use effect based on the current animation and our actions available on the character, we need an animation fade time to do smooth transition. What we will do is we will fade in based on our animation fade time. It is the first one, so if our time is at 0 on the mixer, we'll just directly start the animation without fading. And then when the animation changes, we go and do a fade out. If the message is long inside our use frame, we can add this code, which check if we are at the end of our animation, we will transition it to another talking animation. Let's try it. It is a good day. Now our character is thinking.
いい日です。
And now it is talking with the right animation and it goes back to idle state. If we try to play audio again,
いい日です。
it's working fine. For a better effect when our character is speaking, we can add a loader here. When it is loading, we'll just add the same spinner we have in the typing box component. For this, we are using thinking text, which set 1 dot, 2 dot, or 3 dot every 500 milliseconds. Let's try it. Hello, how are you? We have it on top of us. Almost good. Let's do the final polish, camera transition, and changing the teacher and classroom. Let's add some camera transition when our teacher is thinking and when we are playing the audio. So let's go to Camera Manager. We'll be using use controls from Leva to log the position of the camera and the zoom, so we'll be able to find the perfect position by just moving the camera in our scene. To be able to use it, we need to yarn add a Leva. Then we import it, same for the button, and we need a reference on our control here. So let's say we want the position when the character is thinking. We can zoom, have a look at our teacher here, click on get camera position, look at the console, and it's logging us the position of the camera and the current zoom. Then you create two objects, one for camera position, so in default state in loading and speaking, and another one, camera zoom, for default loading and speaking. Then we just need access to the loading state, the current message, and based on if it is loading, then if it is the case, we set the camera position to the right one. to the loading state and the zoom to the loading state. We set it to true so it enables a smooth transition. Then if our current message is here, it means our character is speaking. So we move to the speaking position. Now we can try it. Hello. It's zooming into our teacher, and when it speaks, it's going back to the blackboard as I set up in my positions. When you are happy with the position, instead of removing the helper code, here you can add a lever and add hidden, so it's not visible anymore. Now let's try to change between the different teachers. For the moment, we are displaying Nanami hard-coded. We simply have to get access to the teacher by doing use AI teacher and get the value from the state. And here, instead of Nanami, we use teacher. Now we are on Nanami. If we click on Naoki, it is correctly loading it, but the issue is it is in T-post tense. It is because our component isn't reloaded with the right animations. What we can do is set a key to the component and assign it to teacher, so we are sure it's a new component that will be loaded when we change the teacher. And now we can switch between Naoki and Nanami. But let's do a check. If we do hello,
こんにちは。
we have the female voice, but if we switch to Naoki and play the audio,
こんにちは。
we have the woman voice. It's not what we want. This is because in our play message, if we already have a message audio, we don't refetch it again. So when we change the teacher, we can update the message to remove the audio player. Now let's try it again. Switch to Naoki.
こんにちは。
We have his voice and go back to Nanami.
こんにちは。
We have her voice. Like we did for the teacher, let's be able to change the classroom we are displaying. So where we have our classroom here, we'll be using our classroom. So we need backtick for it to work. This is fine for the default one. And the alternative one, the scale and position are completely different. To handle it, what we do is we create an object named item placement default, which is the default classroom. We will have the classroom position, but also the teacher position and the board position. And then for the alternative one, we'll have the classroom position, rotation, and scale, and also the teacher position and the board position. Now let's apply those placements. So first on the HTML, instead of the position here, we're using item placement of classroom of board. For the classroom, same apply. We don't want the position from it, but from item placement of classroom. And for the teacher, also on the position, we want the item placement of teacher. Now let's try it. We can switch between the different classroom and it's updated correctly. Same for the teachers. A final effect to add some life to it is to wrap our HTML, our teacher and classroom within a float component, but with very low values. So it's still a bit moving when nothing happens. It is very subtle. You can see that it is a bit moving. So it adds some life in addition to the idle movement of the teacher. Let's see how to deploy our Next.js project with CI/CD on Elestio. It's super easy and fast to set up, and they offer a free trial. On ls.io, if you already have an account, click on login. Otherwise, click on free trial. I will click on login. Because we want to build our own project, we need to go to CI/CD. We have the choice between GitHub, GitLab, and Docker Compose. I will keep GitHub. I will scroll down. I can use one of my repository here. I will be using R3F AI language teacher, but for you, you can go and import third-party Git repository, use the URL of my repository, copy it, and paste it here. But instead, I will go back and use my own project here and click on import. I will deploy it on a new VM on a single node, and I can choose between different cloud provider. I will keep Hetzner and I will keep the region to Germany. Then you can choose between different service plan. I will take the medium one, which includes 2 CPU and 4 GB of RAM, and then hit next. Now it is the build settings for our project. So what we want is a Next application. So it's a full stack one using Node.js. I will keep the 18th version. The framework I'm using, it is Next.js. Now I need to set up the command to build my project. So install is just yarn. To run the project, it is yarn start. To build the project, it is yarn build. And the output directory, I think it is just /. These are the commands you can try locally to be sure it is the correct ones. Then we need to set up our environment variables because we didn't commit our environment local file. Just copy-paste your environment local file if you are using the same keys or use the corresponding keys. Be sure you have all of them and then create CI/CD pipeline. Now every time you will commit, a build will be done and it will be automatically deployed to your instance if it worked successfully. Otherwise, it will be the latest version. When the build is finished, you receive an email telling you your new CI/CD pipeline is ready. You can access it following this link. And here you are using the version hosted on Elestio.
ハンバーガーが好きですか？
ハンバーガーが好きですか？こんにちは。お電話番号を共有できますか？
Thank you for watching. I hope you enjoyed this video. If it's the case, please hit the like button to help other developers dive into the world of 3D web development. Don't forget to use the promo code Wawa Sensei on Fiverr to get 10% off. Tell me in the comments if you want to continue on this project and which features you'd like to see. To continue learning 3D web development, you can jump into my project-based course, subscribe to this channel, and watch my other video tutorials like this one, available here.